Thank you so much, Meredith. I'm Steve Gray. I'm with the U.S. Geological Survey and the Alaska Climate Adaptation Science Center in Anchorage, Alaska. I'm here on behalf today of my fellow co-leads for Priority Area 4, IARPIC Priority Area 4. That's the Hazards and Risk Mitigation Group. And those co-conveners are Anna Lillidahl from Woodwell Center, John Viemeyer from Department of Homeland Security, and Tom Douglas from Corps of Engineers and Corel. It's our pleasure today to have a presentation from Nancy Fresco and Charlie Parr. They're going to, I think, give you all the introduction that they need for the content that they'll be talking about today related to the Arctic-EDS system. But just a couple of words about Nancy and Charlie to give you a little context, get to know them. So Nancy is a research faculty at the International Arctic Research Center, or IARC, at University of Alaska Fairbanks. And she is with the Scenarios Network for Alaskan Arctic Planning, or as we call it, SNAP. Really, Nancy has decades of experience in climate adaptation and planning, with an emphasis on connecting people to the data that they need, or maybe even to say that connecting data to the problems and challenges that people face. I think what makes her work really stand out is her emphasis on doing that in the context of real world needs. And she's been able to do this across an amazing range of stakeholders and rights holders that range from communities and tribes in Alaska to probably, at this point, she's probably worked with every state and federal agency that's out there on the landscape today. And then Charlie is a data scientist also with SNAP and IARC, and I'd call Charlie a data wrangler extraordinaire. His primary focus is on developing interactive web applications, but I think what makes his work so effective is that it's also not only grounded in the fundamentals of data management and data science, but he actually has a great deal of real world on the ground experience with Arctic ecosystems and thinking about the goods and services that they provide. So I'll go ahead then and hand it off to Charlie and Nancy. And thanks again, everyone, for joining us today.
Well, thank you so much, Steve, for that introduction. And yeah, it really has been decades. I'm going to share my screen, and Charlie and I will kind of trade off as we do what is hopefully a rapid but to the point introduction of this tool, leaving plenty of time for question and discussion. I know a lot of the people on this call. There's some others I haven't had the chance to meet yet. So it's fantastic to get to talk with this group. And thank you very much for inviting us to this opportunity. So with that, I will try to avoid doing death by PowerPoint here, but I will jump into a screen share. Let's see. Okay. So as Steve already said in the introduction, we're going to be talking specifically about this new tool. And when I say new, I mean really new, as in it is still being tweaked, changed based on feedback that we're getting from engineers, from people who want this data, who are using this tool, which is really exciting for us, knowing that people are actually engaged using data, even if sometimes that means the feedback is, change something, alter something, make it more usable. So this opportunity gives us another chance to put it out there and to hopefully not just hear back from you during this talk, but in the future as well. So I will go through just a little bit. This is the screen to remind me to say that this is absolutely, as with everything that we do, it's absolutely a team effort. And I am not a data wrangler. I'm lucky that Charlie is backing me up in the talk today because he is a data wrangler extraordinaire, but there are many others on the team as well. We have web designers, we have communications experts, scientists, and we're all on Slack all day long, trying to work together and share skill sets. And there are many others besides those in this core SNAP team who have put considerable brain power into many of the products that we create. Everything we do is a collaboration, and that is extremely exciting. So in the interest of moving quickly through here, SNAP, the Scenarios Network for Alaska and Arctic Planning, creates web tools as one of our primary products. The idea being, and here is a screenshot of our current web tools. The idea being that, as Steve said in the introduction, we're trying to connect people to data and data to people. It's a tall order because different groups, different organizations, people with different background, different knowledge need really different things and have different questions to answer. We're obviously not going to talk in the next 20 minutes about all of these tools, but I wanted to put this up there to introduce people to the idea that we try to have something for everyone. Some of these are very technical, very specific tools created for specific purposes. For example, for the Department of Transportation. Others are much more broad and they're created for the public, people who might have very little technical background. All of them are different windows into the climate data and climate projections that we have. So I'm going to be talking specifically about this Arctic engineering data support tool. As noted, it is still being tweaked, it is still being changed, but tying it to the subject at hand, which is hazard mitigation. The idea behind this tool is that it would provide a very specific and hands-on way for people who do have a significant amount of technical background in engineering and related fields to address the specific types of questions, problems, and issues that come up in construction, in development, or in environmental planning associated with construction and development. And so in developing this tool, we've tried to go back and forth with some of those stakeholders. Oh, sorry, I'm hearing some background noise. If you just forgot to mute yourself, go ahead and do that. But if you do have a question, feel free to jump in and interrupt me if I've said something off base or confusing. So we're going to do a live demo of this in just a moment, but these are some screenshots to give you the idea that what this tool offers is a basic interface where you can put in, you can select a location by community name or longitude across the state of Alaska. And from that, you're going to pull up results that include very specific projected data for precipitation, for temperature, and for indices derived from those climate variables. And that the results of this are available as a URL. So the point being that with this tool, the tool itself is a window into a much deeper and more complex data set. Again, a few screenshots to get you oriented. So for example, among the results would be these results that give just a taste of the hydrology data available. We can show you a bit more in a live demo, but all of this kind of information could be used to plug into the type of indices, the type of rubrics that engineers might already be using to figure out flooding risk, to figure out the danger of thaw collapse, anything that might be hazard related or more trend related, such as long-term permafrost thaw. And there are also these indices, again, plugging it in to calculate heating degree, freezing index, and so forth. Sorry, advancing here. Whoops. Sorry. And in addition, as well as the data and tables and the links to the full data sets that come up, there is a tab within the tool that takes you to climate maps. These are visuals so that you can look at the same data rather than for a specific point. You can just quickly eyeball statewide data. The one I pulled up here is mean annual ground temperature at a depth of 1 meter. And the one that's highlighted and shown in the map is a long distance future projection. So mean values average across the 2070s, 2080s, and 2090s. So a 30-year long-term average for ground temperature at 1 meter depth. You notice from the color patterns that massive thaw is projected across the interior. So regions that are currently underlain with permafrost are very likely not to be by the end of the century. Again, the data for these maps is available, but sometimes taking a look at it visually can be helpful. I'm going to turn things over to Charlie now to quickly talk about what is underlying this tool, our API. So take it away, Charlie.
Thanks, Nancy. Yeah, the API or application programming interface is something that we're really proud of at Snap. It's the technology that allows us to build this web application. And essentially what it does is it allows interactive web applications to talk to a database containing terabytes of climate model output, ecosystem model output, geophysical model output, and allow users to very rapidly extract data from that large corpus for a single point. And the way that our applications do this is they make a menu order essentially in the form of a URL. So if you went to this URL, earthmaps.io, there would be documentation for all of our API services or endpoints. And those allow users to get information about temperature, permafrost, any of the data that we host. And this is how we build our applications, but also other people can build applications that talk to our data in this way. Anybody can use this API, and it also allows some sort of more custom data queries, such as getting data back in a CSV form for a specific location or a specific sort of subset or summary of the data that we offer. So the API is something that we're really excited about. If you have questions about this, please let me know. But this is kind of a low-level technical detail, but it is something that we like to talk about when we're showing our tools because it makes our work possible. And another piece, should I keep going here, Nancy?
Yes, we can do a quick demo if we have time, but there are a couple
Yeah.
of slides in here about this.
Yeah. So another piece of the Arctic-EDS are embedded computational notebooks. So providing some starter Python or Jupyter notebooks where users can use this data in an analysis. The example that you're seeing here are these precipitation frequency futures for a couple different climate models under a RCP 8.5 scenario. And this Jupyter notebook is computing a design discharge value based on some user parameters and that same data that you saw in the table. So it's a way for users to get started, maybe using these data in their engineering or hazard mitigation application without having to download anything, without having to install software. They can maybe have an idea of how this might fit their existing workflows. Yeah, so we've got
Great.
sample code to build on.
Excellent. Thank you, Charlie. I'm not doing the best job driving the slides,
No, this is
but we
good. We're
had,
in perfect
yeah.
sync.
And this was the last one here that obviously for those who want to take a really deep dive, you can just go straight to GitHub and yeah, do everything from scratch. So we try to have it on multiple levels, even though this is a tool for people who are relatively tech savvy, but there are different levels of tech savvy. So yeah, there are people who want a CSV. That's something that's my level of tech savvy. Oh, it's a spreadsheet. I can deal with that. But and yeah, we're still trying to develop these to be as useful as possible to the widest range of users as possible. I'm going to quickly take us to a live demo. I know we're short on time, but at the same time, it's a lot more fun to see this as something actually in action here. So I'm going to redo the screen share. And this time I'm taking you to our homepage, which you see right now highlights a couple of new tools. The Northern Climate Reports is one a little more aimed at ecologists such as myself, but I'll jump into the tool at hand here. And this is the same thing that you saw as a screenshot, but here you can type in, and you see if even if you don't know exactly how to spell the name of the community that you're typing, if you can get in the first few letters, it'll pop up and say, are you looking for Anchorage? We've done our very best to include Indigenous place names. If you see any that are in error, by all means, speak up and we'll correct that. So now I've selected Anchorage. I could have put in a lat long, but I've put in a place name, and you get a summary here telling you everything that's available, a summary of the report contents, some notes, mini map specific to the location, and then a table of contents, which is clickable. And so you can see all the different data that's available, precipitation. The indices are particularly interesting, I think. It's a little newer than some of the other data that we've been able to offer in the more distant past, in those decades that I've been working at Snap, because we are now wrangling daily and even hourly data rather than just, very averaged monthly type values. Trying to figure out how best to use this more temporally fine scale data is an interesting puzzle, because of course the more you hone in on thresholds, the more the precision becomes an interesting and sometimes thorny problem. So this gives you a window into the summaries that pop up, and then the invitation to download the whole thing. So a preview gives you a sense of, oh yeah, this is the data set I was looking for, and then the invitation to download the CSV that you're seeing as a preview. And then this is what Charlie was talking about, where you can click through to some of these modules or tools or Jupyter notebooks within here. So this just gives a sense of the way the interface looks and the richness of the data connections here. Charlie, would you like me to click through, or actually, you know what? I'm going to stop sharing and let you share on your own so that you can take that slightly deeper dive. So this is the immediate scroll through. I'll stop sharing and turn it back over.
Sure, I can do that. One moment.
Yeah.
All right.
There we go. It adds a layer to
Okay.
the juggling. Go for it, Charlie.
All right. So I'll pull up a different report. Let's see. Arctic Pass, one of my favorite places in Alaska. And so this report is the exact same format as the previous report that you saw for Anchorage. We have a lot of text about uncertainty and things that may cause, these model projections to depart from historical observations. Some information about the elevation and just sort of the general geology and ecology in the place that's been selected. And I think what we'll do then is we'll maybe go through to one of these modules and see how well that works for us. But I guess I would also highlight before that there's a lot of off ramps here in these data reports. So we have a summary data table showing some trends over time. These are across several climate models and several emission scenarios. We offer a preview of what the entire data set would look like if you were to download it. Here's the CSV or spreadsheet, just a tabular data format that users can drop into Microsoft Excel or whatever their preferred analytical tool is. We also provide references to the source data sets. So what are the actual gridded data products that these reports are pulling data from via our API? And then also we provide links to whatever relevant academic references are sort of tied to the source data set. In this case, it's a Walsh et al. 2018 paper for downscaling climate model output. But if we look at our precipitation frequency, this is the same data that you saw in one of our screenshots. Here, this is a little bit different layout. Users can choose different eras. It's really important when we work with climate futures that we look at large periods of time, not just single time slices. And so you can change eras. You can also change which climate model that you'd like to look at and just examine how the different annual exceedance probabilities for a precipitation event of some duration change with different future periods and different climate models. And of course, you can download this data, get a technical report, get some academic references, but we also have a off-ramp where you can try this in a computational module for design discharge. And I haven't clicked this link in a while, so hopefully it works. But basically, it's going to open up a Jupyter notebook, a computational notebook that's running in your browser. And we've got a latitude and a longitude. You could change these to pull up a different place. It's going to request the data from our API and spit out a table like this. So we have that precipitation frequency value, and then as well as a lower and upper bound. So those are the numbers that you saw in the table. And when you execute these cells, you're then able to, okay, there's a little bit here. All right, let's see what happens if I try to run this. No guarantees on the live demo here. So I'm just executing these cells one by one. Let's see if it can get the data and generate that data frame that we just saw. Okay, that's good. It's talking to our API. And I'm just going to move pretty fast here. There's a little bit of conversion to get us started. Okay, so here's the slider. So this is a just very simple example notebook for, I think, a rational method for computing design discharge. And so we can select our return interval that we want to compute for. So maybe 50 years, our duration of our precipitation event. We could change it to 2 days. You'll notice the numbers update. We can change our drainage area. The numbers update. We can change our runoff coefficient as well. So that's an idea of the sort of applications that we're trying to build around this data, and the types of use cases that we hope that Arctic-EDS users can use the tool for. So I'll stop sharing there, unless Nancy, if you think there's anything else.
No, that was a fantastic overview. Thank you, Charlie.
I'm
And
glad
you,
of it.
yeah. Yeah, well, yeah, and it's tough because we could Charlie and I could talk for hours about this. Thanks for touching upon a couple things that I blew past. Particularly the text that explains some of the uncertainty, explains some of the methods. We're actually going to be fleshing that out even more in response to feedback. And also the key point that we offer data on more than one model and more than one scenario, meaning the climate futures as defined by the IPCC, because of course it's tricky connecting the precise types of measurements desired by engineers with the uncertainty of futures offered by the IPCC and anyone else who looks at climate modeling, climate futures. And striking a balance between that, such that we are genuinely producing a reasonable and I dare to say an important range of climate futures and climate scenarios is our goal. And then with reference to the notebooks and the flexibility that Charlie was demonstrating there, we did try to listen to feedback in terms of what types of tools have practical value, what types of variables are of interest in terms of runoff, that sort of thing. And as we circle into questions here, obviously the goal of this discussion was to tie this into hazards and hazard mitigation. Hopefully the connection is obvious. If you're looking at something like runoff, the goal is to prevent flooding, to have your culverts and bridges and structures built so that you were developing them to deal not with the extremes that were true in the past, but the extremes that might be true in the future. So being able to pinpoint projections for extreme values is a priority now, and that priority has a lot to do with hazard mitigation, whether it's hazards to human health from extreme heat, hazards due to permafrost thaw, to flooding, to actually a lot of other extreme engineering type variables. But we are, I know, very short on time, so I want to stop talking and see what questions or comments people have at this point.
Great, thanks so much. All right.
Should I call on people, or are you the MC here, Steve? I saw Jacqueline, you had your hand up first.
Thanks for the presentation, Nancy and Charlie. And yeah, absolutely see the connection to engineering for hazards. That's an area that I work in, particularly as it relates to coastal hazards. And one of the things that I do in working with communities and with engineers is provide guidance on what the best available tools are for making these estimates. So for sea level rise, it might be a NOAA tool, something like that. But in the case of climate scenarios, I guess I want to ask, is this the best available tool and best available data? And how are you determining that? How are you keeping that data up to date so it does remain best available? And you mentioned the caveats as well. Like the modeling is only as good as what we can do today. And so I wonder if you have any suggestions on moving into the future, making that data better so that engineers do have access to information that is more useful at the community scale.
That's a great question, and to some degree I can defer to Charlie on that, but the SNAP team right now is very heavily immersed in basically incorporating the CMIP6 data, the newest, latest, and greatest climate data, including thinking a lot about not just downscaling the data, but creating new indices, and there's a lot of ongoing discussion among the team right now about how to do the best job possible, not just wrangling the best data, but putting it into, well, I can let Charlie talk about RDAC, but making as smooth a possible connection between, for example, what modeled baselines we use and modeled projections. Charlie, is there anything you'd like to add to Jacqueline's specific question for community needs?
Yeah, I guess really quickly, I would just add that, we strive to have the best available data, but a lot of that is working with our collaborators. Nancy mentioned that, everything that we do is a collaboration. And so, when we're working with, a PI that's building a data set like that we're using here, as that data set gets updated or changes, that's something that we track very, very closely. Nancy mentioned that, we will be at some point updating our climate futures to sort of this next CMIP6 generation. And just as a very specific example for our degree day data sets, so our freezing index, our thawing index, heating degree days, we'll actually be updating those in this tool very soon with a data set that recently came available to us that has more models, more scenarios. So it is a living tool.
Yeah,
That's
and
great.
we're always looking for which data set is meets the user needs and has the greatest precision, the greatest accuracy. It's tough because everyone always wants very high precision in the sense of fine temporal scale, fine spatial scale. It can be a tough challenge trying to maximize that. And sorry, I cut you off, Jacqueline. I also want to get to Sandy, who's been waiting with her hand up. But sorry, what were you going to add there?
Oh, I mean, if there were any recommendations on what might be lacking in the tool to utilize at that community scale, I wonder if that is like a caveat that could be pretty explicit within the tool, just to understand that. Like if greater downscaling is required for that particular location, that would be really good to know.
And that's I'm laughing because that's what we've been really heavily immersed in discussing right now. Because we always hesitate to put too many words into tools, because for a lot of the tools that are aimed at less technical users, it's intimidating to have a README that's pages and pages long. This tool, we've really decided we need to be extremely explicit and detailed about what those caveats are. Essentially everything you're saying, to make it very, very clear in what ways the data can be used and what ways it can't be used, if there's further downscaling needed, if there, if there are ways to make the data more usable to our end users and more transparent at every stage. So yeah, let me quickly shift over, since Sandy's been waiting to ask a question, and then Jeff after that.
Yeah, super interesting. And I mean, the nice thing about a virtual hand is you don't get tired holding it in the air. So no worries if you want to make sure you've thoroughly addressed this this point. But maybe this feeds into it. So your work, I always learn so much from your presentations. And one of the things that I came to learn about today and was curious about is, how do you receive guidance from your user base about what they need? How do you like network and understand around these different use cases? Do you guys have like a generalized approach that you use, or is it more kind of ad hoc and depends on what you're developing, that kind of thing? I heard Charlie mention hearing from your collaborators. And so, yeah, as you said, there's so many different use cases for this information. How do you guys wrap your arms around that, asking for a friend?
Yeah, no, very briefly, for this particular, for Arctic-EDS, we had engineers kind of on board from the beginning, like advisors that we were working with and bouncing things off of. So the short answer is it's different for each use case. So different tools we expect to be used by different people. And so we have different alpha testers, beta testers for them. In this case, yes, we did try to incorporate that from the very first, and we had, sending out emails and trying to have one-on-one discussions with particular individuals. But we're always getting more general feedback. All of our tools on our website have big friendly buttons all over the place that say, if you're having a problem, you have questions, email. And it goes to an email called Snap Data Tools that actually goes to all of us. And we actually have a running joke that everyone is Charlie, because we had one back and forth, really wonderful, in-depth feedback with a user who had a bunch of questions, and all of us from that email thread were jumping in and out, answering different parts of it. But that particular end user got confused and thought that all answers were coming from Charlie. So you can just believe that all answers come from Charlie. We really, really do welcome getting those emails. We'll get an email with an interesting question, and immediately we'll be, talking to each other on Slack of, oh, who's going to field that? And wow, that's a great response. How do we handle that? So yeah, the short answer is that the official methods for feedback depend on the task at hand and the tool we're developing, but also that you can always email any of us individually or as a group, and we really, really do appreciate, even if the feedback is someone saying this doesn't work for me at all. The more specific you can be about what the struggles are, what the difficulties are, and what the needs are, of course, that makes it easier for us to figure out, what we can do differently, how we can explain things more clearly, how we can increase transparency, and so forth. Is there anything I missed in that explanation, Charlie?
No, I think you nailed it.
So we can move on to Jeff, and I apologize for my two pets that keep trying to join this discussion.
Jeff, you're muted. And I'll also just take a moment to say, Nancy and Charlie, I think we're okay on time. We probably have 15 minutes left of discussion, so no need to rush things along. Although I'm sure,
great.
Yep,
Great.
people have plenty of questions.
Yeah, I'm Jeff Curry. I'm Alaska Department of Transportation Materials Engineer. At least this week. I'm retiring next week. But
Congratulations.
thank you. Am I correct? The EDS. This is the modern version of the historical environmental atlas that was published back in 1984 or something.
That was the original dream. It has grown to great proportions beyond that. Yes, but
it
yeah.
sure has. I'm very impressed. And to answer Jackie's question, I for one was solicited early on in the, what do we need? And I'm not sure I gave it as much effort as attention as I should have, but I'm very impressed. But I do have a question where if you look for data based on a lat long that is not near a data source like a community or an airport or something where there's some historical data, how does the program interpolate or determine historical and future scenarios middle of nowhere?
That's a great question that gets at what I think a lot of people are struggling with the data, and I'll let Charlie follow up. But yeah, we obviously need to be much clearer about the fact that these gridded data sets are all essentially based on interpolation and downscaling, and so the data is only as good as the interpolation method. The short simplistic answer is that historical data, of course, can only really come from climate stations. There have been different interpolation methods, such as the CRU data, the PRISM data, that takes into account slope and aspect and distance from coasts, and mathematically creates grids from what you're completely correct in saying is actually incredibly sparse historical climate data. So there is a struggle in understanding and interpretation the difference between what most people understand as historical data, which means someone at a weather station in a very specific location measured something. They measured temperature, they measured rainfall, they measured wind speed, versus what we modelers who've been immersed in model data for far too long think of as historical data, which is actually interpolated, it's modeled. Charlie, I'll let you delve deeper into what all that gridding really means on the data side of things.
Yeah, it can be a bit complicated. So in the tool, if you see something that says historical, it's gridded. So it's a map without a gap of whatever climate variable that you're interested in. And those can get generated in two ways. The first is that it's just an interpolation of historical point measurements. And so, of course, you're assuming, some amount of spatial correlation between points, and that is one way a gridded data set is produced. I should note that we at Snap are not doing any of this interpolation ourselves. These are data products that are already sort of produced by other research groups. Perhaps some of these ones that people may be familiar with are DayMet. That's something from Oak Ridge National Labs. There's also this CRU-TS data set that's produced by, I think, a research group in the UK. There's also the PRISM climatologies. So people may be familiar with some of these. The other way that we have historical maps without gaps are through reanalysis data. So these data sets create these historical pictures, not just through weather station records, but they may sort of assimilate other data sources like weather radar or satellite imagery, and then also use a weather model to sort of get a picture of how things might look where point observations aren't available, and to also capture maybe some more realistic dynamics that you wouldn't get with just a statistical interpolation. And then this is how our climate models that also have maps without gaps, except in the future, are able to reference a historical baseline and be downscaled. So to have a portrait of everywhere in the future, we need a portrait of everywhere in the past. And identifying what's the historical sort of model baseline versus what's an actually observed point-based station value is something that I think we're still learning to communicate about, and that we hope to improve in some updates here for the Arctic-EDS going forward.
Thanks. That's a super explanation.
Yeah, thanks, Charlie, for filling that in, and thanks, Jeff, for your praise of the tool, and for pointing out that yes, the original dream was to update that paper atlas from the 1970s and 1980s, which we did start with. We pulled old copies from Rasmussen Library, and I had them on my desk looking like archaic relics. So it is genuinely exciting to see how much more we can do now. And we have actually laughed a bit about how when you have more data, it is in one sense it obviously increases the value of what you can offer, but it also can create some dangers and red flags, because when someone looks at an old paper atlas from 1984, they do assume that things are kind of, you know, averaged and smoothed a bit. And you know, the assumptions about the precision of those data sets are very different from the assumptions about the precision of a really modern data set, you know, that you're finding online and that you can zoom in on, and you can do this and that. So having those caveats, having those explanations, reminding people what a gridded data set is and what a gridded data set isn't, is really, really crucial. And the fact that it's more than one answer, that it could be, you know, an interpolation of actual climate station data, it could be an interpolation of modeled data. Those things are different. They're both useful. They're useful in different ways. All of that does have to be spelled out. It's tricky to do it without using too many words. And of course, our talented web designer, Carolyn Rosner, is torn between trying to have web design that actually looks good, and web design that contains all the words about all the things all the time. It's a juggling act, and it's a fun challenge, but it can be frustrating for us and frustrating for end users. So we try to keep having that conversation.
I appreciate the dilemma, and I just took my copy of the old environmental atlas home last week, so.
Oh, excellent. I honestly love the fact that some of those are still out there. I can be a little old school myself at times. Steve, go ahead.
Yeah, just real quick, this may actually be the last question of the meeting, but I was wondering if you could just speak briefly to some of the other uses or systems that you're developing or have already been developed using this API approach. Just kind of give people a sense of the different levels of or target audiences that are out there, and approaches that are being used with this kind of as the foundation of what you're doing.
Oh, that's a fantastic segue, and I'm just tempted to jump into a very quick demo of the Northern Climate Reports, which was the other tool that was highlighted on our homepage.
Just to clarify, we've got 15 minutes or 14 minutes left. So just so people, if you want to do a demo, that would be okay. If you think it fits in.
I'll do that. I'll do that really, really quickly. I won't belabor it, but that's a great question about the API. On the technical side of things, that's Charlie's ground. But I did want to, the power of it is pretty exciting, because we've been highlighting some of these very specific data sets that can be accessed, but there are users who want something that's much more summarized, much more of a story, much more of a narrative, and we want to be able to meet their needs as well. So just really quickly, taking us back to our homepage. Am I screen sharing there correctly? I think I am. So if I go to this tool that's called the Northern Climate Reports, this is a tool that also accesses the API. It was in development at the same time that Arctic-EDS. It just happened to overlap. It comes from a very different background, is intended for different users. Very briefly, it's an offshoot of a long-standing project with many, many collaborators. That was the Integrated Ecosystem Management Project, the IEM project, which pulled in a lot of ecological background related to fire, related to ecological mapping and species mapping. But very quickly, the idea here is that you can again search by the name of a particular community or by lat longitude. But here you can also search by spatial regions. So if you start typing in let's see, here we can pick anything. We can pick the Misty Fjords National Monument, because that's what popped up. And so you see you have all these categories of locations.
Nancy, you're not sharing the screen anymore for some reason.
Oh, that's odd. It says that I'm sharing screen.
Hmm.
Huh. Let me stop share and start again. Sorry, I won't, let's see, that is odd.
Thanks, Charlie, for dropping those links in the chat also.
Yeah, I'll try to share again. Is the share working this time?
Yeah.
Okay. And I'm just, this is quickly showing a tool that's very different, but also very powerful in terms of how it uses the API. So this is pulling from the same, some of the same data sets even. But here, in terms of what's being given back to the end user, is a summary at the top, and testing this out with people who are fairly novice, who are not particularly well versed either in climate data or in data sets in general. They find these friendly summaries at the top really helpful. You get a little zoomed in mini map. You get a summary that says, in the location you selected, Misty Fjords National Monument, average annual temperatures may increase by about 9 degrees Fahrenheit by the end of the century. And this text is generated on the fly. So the key point is that this data is being pulled from the API and turned into what you're seeing here, a summary at the top, where it's pulling out some of the key points, some of the things that are changing the most, kind of the takeaway, the narrative message. And I might not have picked a particularly interesting location in terms of how extreme the change is, but the introduction here helps guide fairly novice users into what location, some of the key geographic points of the location they've chosen, and a little bit of background for people who might be very unfamiliar with representative concentration pathways, with the idea of having different models, different scenarios. And so it guides people through. You can choose imperial or metric units, and at any point you can take a screenshot. The goal here is to give people something that is for the location of interest, for their community, or for conservation area of interest, where they can pull out information as an image, as a CSV, things that are kind of the lowest common denominator of usability, and put it into a presentation, use it in a report, use it when speaking, whether trying to find funding for a community climate change adaptation project, trying to talk to people about changes they're seeing in their community, or using it for a specific ecological narrative. But at the same time, we're not oversimplifying, we're not dumbing down the data, so to speak. These graphs that you're seeing include the full, well, not the full range, but a sample range of models and RCPs to remind people that there are multiple futures, there are multiple scenarios. In this case, showing all of these potential futures show significant warming, but that varies quite a bit by model and scenario. And so you'll notice these big, obvious buttons inviting people to download temperature as a CSV. To answer the question that was being asked, this is pulling directly from the API. So it's pulling from the data sets, and it's doing this on the fly, but it's offering up a very different interface, where you can, again, pull these tables as an image. You can download them as a CSV. You've got mini maps. These ones are not particularly interesting because mean annual ground temperature is already fully thawed. This is not a permafrost area. But because you can do this for any location and all these different regions around the state, there's quite a bit of variability. There's fire modeling. Again, this happens not to be a particularly interesting area for fire modeling. But all the tables are pulling directly from the API again, and the vegetation change linked to fire. This is what I like to think of as the world's most boring bar chart, showing no fire-related vegetation change because I picked an area that's not particularly fire prone. But yeah, that's just an example. Charlie, would you like to say more about different ways that we're going to be using the API in the future? I mean, in addition to using it in these particular tools.
Not off the top of my head, I've been dropping some links in the chat to our data catalog, to our API homepage, so people can sort of have a full picture of the different types of data and different types of data services that we offer. I guess I would just say that it's always being updated. It's always changing. Definitely the biggest thing on the horizon is our CMIP6 efforts. So having a new generation of high performing climate model output that's really focused on Alaska and the Arctic. So that's something that we're really excited about. But no, nothing else to add.
Oh yeah, but I hadn't been following the chat. So yeah, you had dropped in there the historical sea ice atlas. That one is really, that's an interesting one to highlight, because we're talking about different types of data sources. The tool itself, if you explore it, includes information about where the data came from. Talking about the difference between model data and measured data or interpolated data. There are no projections, it's historical only. And obviously some of it had to be at least somewhat interpolated. There wasn't someone out on every square kilometer of sea ice for over 100 years. But those interpolations, the data they came from, include logs from whaling ships. So we do, when possible, try to include really, truly the full range of available data. So explaining where the data come from is really important. Using the best data available means really different things in really different contexts. And that might include indigenous observations. It might include, something you would expect, like weather station data, and, really everything in between. And we do welcome feedback on that, obviously. So yeah, we've covered a lot in a short time. New things on the
You definitely
horizon.
have. Yeah, we really appreciate you coming today, both Nancy and Charlie. I think with that, we're going to have to wrap up the presentation portion. And thanks again, Nancy, Charlie, for your time today, and thanks everybody for attending. Meredith, I believe you have an announcement for us.
Yep, I have two. One is that if you're located in Fairbanks, there on Wednesday, May 8th at 6:30 at the Museum of the North, there is a permafrost discovery gateway. Virtually visit the Krell permafrost tunnel tour using VR headsets and meet scientists and Googlers who are generating the big geospatial data sets and tools to make the information accessible to everyone with internet. So if you want to do that and you're in Fairbanks, you can reach out to Anna Lilladal, whose email I have just put in the chat. I also want to take a second to let everyone know that IARPC is currently in the process of updating our implementation plan. So that gives us a map for what we focus on in the next 2 years. And this risk and hazard mitigation team certainly is a big part of that. And we really encourage everyone here to let us know what we should be focusing on in the next 2 years. And there's a form there that I have also just put in the chat with more information about that update, and really encourage folks again to let us know where we should be spending our energy and efforts. And that form is open through the end of May.
All right. Well, thanks so much for that, Meredith. And again, one more time, thanks to our speakers and everybody who was able to join us today. I think with that, we can go ahead and wrap it up, unless you have something else, Meredith.
Thank you so much for inviting us. Really appreciate it.
Yeah, thank you. Thanks, everyone.
Thank you.